For every person alive on this planet, there are 2.5 million ants, 20 quadrillion of them, more dry carbon than all wild birds and wild mammals on Earth combined. But the strangest part is not that there are so many of them. It is that they have already survived 5 versions of the end of the world, and they will probably survive ours too. The last human city will not end all at once. It will go dark in pieces. A pump will stop. A tunnel will flood. A basement archive will mildew. Grass will split the roads. Roots will lift the sidewalks. The steel inside concrete will swell with rust until the buildings begin to unzip themselves from within. Somewhere under that broken pavement, a queen ant will keep laying eggs. She will not know there were once banks above her. She will not know there were satellites, borders, stock markets, languages. She will sit in a chamber smaller than a walnut, blind in the dark, fed by daughters she will never recognize as individuals. The colony will keep moving soil, grain by grain. And the strange thing is not that ants are numerous. The strange thing is how many different versions of the end of the world they have already survived. 66 million years ago, a rock larger than a mountain struck what is now the Yucatan Peninsula. The sky filled with pulverized earth. Forests burned. Sunlight thinned. The food chains that ran on green leaves began to collapse. The dinosaurs had size, teeth, speed, armor. They had ruled the land for more than 150 million years. Ants had tunnels. Down in the soil, in narrow galleries pressed between roots and stone, their colonies waited inside the dark. The surface world starved. Underground, the rules were different. Dead plants fell. Dead animals fell. Fungi grew through the wreckage. The planet had become a banquet for scavengers. That is one of the first clues. Ants do not need the world to be stable. They need the world to contain something dead, something broken, something spilled, something soft enough to carry. When the light returned, the dinosaurs were gone. The ants were still there. They spread into forests, deserts, floodplains, grasslands, kitchens, hospitals, electrical boxes, ships, farms, sidewalks, and the seams of human civilization. They did not conquer the earth like an army crossing a map. They occupied the places that every other animal forgot to defend. A queen begins the same way. She rises into the air once. On the day of her mating flight, she leaves the nest with wings she will use for a few minutes and never again. Males swarm around her. They mate in the air. Most die within days. She drops back to Earth carrying enough sperm inside her body to fertilize eggs for years, sometimes decades. Then she tears off her wings. She digs a chamber. She seals herself inside. There is no food down there. No help. No exit. For weeks, she survives by digesting the muscles that once powered flight. Those muscles become the first meal for her first children. The first workers are small because the queen is starving. They hatch in the dark, pale and soft, and their first job is to open the tomb without being eaten by whatever is waiting outside. If they succeed, the colony has a future. If they fail, the queen dies in a hole nobody will ever see. This is the bargain ants made with evolution. No individual matters very much. The colony matters almost completely. A human body has organs. An ant colony has workers. Some nurse the young. Some dig. Some carry the dead. Some forage in the open, where spiders, birds, heat, parasites, floods, and rival colonies take them one by one. The old workers go outside. The young stay deep. It is not kindness. It is math. A forager can die without costing the colony its future. A nurse cannot. A queen cannot. So the colony spends lives in the order that hurts least. That is why ants are difficult to kill. You are not fighting an animal. You are fighting a distributed body. Step on one ant, and the colony loses a cell. Step on 100, and the colony changes its route. Flood the nest, and some species become boats. In South American floodplains, fire ants have learned what humans usually need engineers to solve. When water rises, the colony does not scatter. Within minutes, thousands of ants lock their legs and jaws together. Their waxy bodies trap air. Their woven bodies form a floating raft. The ants on top walk on their sisters. The ants underneath breathe through silver bubbles trapped against their skin. A raft can hold a queen, larvae, eggs, workers, and the future of the colony. It can drift until it touches land. Then, the living structure unfolds, and the ants become a colony again. Fire ants did not invent survival as a metaphor. They made it physical. In the Sahara, another ant waits until the desert becomes almost empty. At noon, when surface temperatures can climb past 140 degrees Fahrenheit, Lizards retreat. Spiders retreat. Other insects vanish into shade or sand. This is when the Sahara silver ant comes out. Its body is covered in tiny triangular hairs that reflect sunlight. Its legs move so fast that its feet barely touch the ground. It runs across sand hot enough to cook tissue, counting its steps, reading polarized light in the sky, calculating the way home because chemical trails evaporate almost instantly in the heat. A worker may have only minutes before its own body fails. It leaves the nest, finds the corpse of an insect that died in the sun, and races back with food before the desert cooks it alive. This is not bravery. This is a job assignment. Somewhere else, a trapjaw ant opens its mandibles until they lock at 180 degrees. The jaws sit loaded like a spring. A hair is touched. The jaws close in a fraction of a millisecond at speeds around 230 kilometers an hour. Sometimes the strike kills prey. Sometimes the ant fires its jaws into the ground and launches its own body through the air, escaping a predator by becoming a projectile. A body smaller than your fingernail has turned its face into a catapult. In India, the story gets stranger. In most ant colonies, the queen is the queen, and the workers are workers. The roles harden. The colony lives inside that order. In the Indian jumping ant, the queen's death opens a month-long contest. Workers duel with their antennae. The winners begin to change. Their ovaries expand. Their venom systems shut down. Their lifespans stretch from months into years. Their brains shrink. A worker becomes a reproductive female by surrendering part of the organ she no longer needs for the old life. If she loses status, the process can reverse. Her brain grows back. Her body returns to work. In a human, identity feels like a self. In this ant, identity is a switch the colony can throw. That is the second clue. Ants are not built around personality. They are built around roles. When the world changes, the role can change. The body follows. Humans have spent most of history imagining the apocalypse as a contest of strength. Bigger machines, better shelters, harder materials, more power. Ants took the opposite path. They became small enough to hide from catastrophe, numerous enough to absorb loss, flexible enough to rebuild, and organized enough that no single body needed to understand the whole plan. Even radiation does not fit the story we tell ourselves. The animal people usually put at the end of the world is the cockroach. It has become the mascot of ruin, the creature skittering through the nuclear kitchen after humanity has burned itself out. In laboratory tests, newly mated queens of the black garden ant have survived acute X-ray doses around 250 gray. For humans, about 10 gray is generally fatal. Part of the reason is timing. Many insects do most of their cell division around molting. Cells that are not actively copying DNA are harder for radiation to ruin in the same way. Add a nest under soil, add efficient repair, add the fact that a colony can lose many bodies and still function, and the picture changes. The post-human world may not belong to the cockroach. It may belong to a queen under a patio stone. The third clue arrived on ships. The Argentine ant began in South America as one more small brown insect among countless others. Then, humans built global trade. We packed soil around plants. We moved fruit. We filled cargo holds. We made ports into revolving doors for living things too small to notice. Argentine ants came with us. In their native range, neighboring colonies fight. Their chemical signatures differ enough for ants to know who belongs and who does not. But the ants that traveled abroad passed through a genetic bottleneck. Far from home, huge populations smelled enough alike to stop treating each other as enemies. A worker from one nest could meet a worker from another and not attack. The boundary dissolved. In Europe, one supercolony stretches thousands of kilometers along the Mediterranean. Ants from distant points along that range can recognize one another as kin. They share food. They cooperate. They act less like separate colonies than a single loose empire with many mouths and no capital. Humans invented passports, walls, customs officers, trade agreements, shipping lanes. The ants used the shipping lanes and ignored the rest. By the time anyone understood what had happened, the colony was not in one place. It was in too many places to remove. This is where ants become difficult to think about, because human beings are very good at killing animals and very bad at killing systems. A bear can be hunted. A wolf can be trapped. A mosquito population can be suppressed if you find the water. An ant colony is a decision-making structure made of bodies. It can relocate. It can split. It can seal tunnels. It can sacrifice workers. It can hide its reproductive future underground while the surface appears quiet. Even the suffering built into ant life feeds the machine. A carpenter ant in a tropical forest can be infected by a fungus that enters through her exoskeleton and grows through her body. The fungus takes control of her muscles, walks her away from the colony, makes her climb to the underside of a leaf, and locks her jaws into a final bite. A stalk erupts from her head and rains spores onto the forest below. The colony loses a worker. The colony continues. Slave-making ants raid other nests, steal pupae, and chemically absorb the stolen young into their own society. Desert ants cook. Flood ants drown slowly under their sisters. Foragers vanish by the thousands. The colony continues. That sentence is the engine of ant history. The colony continues. A single black garden ant queen has lived almost 30 years in laboratory conditions. For 3 decades, one body in the dark kept producing daughters. The workers changed. The seasons changed. The people watching her aged. The queen kept laying eggs. If you live in a city, ants are already inside the human world that feels most sealed. They move through wall voids, under slabs, along cables, behind outlets. They find the sugar in a kitchen, the grease under a stove, the damp wood behind a bathroom tile. In some places, they short electrical equipment by gathering around warm relays and switching boxes until their bodies bridge circuits that were never designed for life. You may never see the colony. You see the line. 1 ant appears on the counter, then 3. Then a dark thread forms between the wall and the crumb you missed. The visible part is not the animal. The visible part is the colony reaching out a finger. Humans are young at this. Our species has been here for a few 100,000 years. Agriculture is about 12,000 years old. Cities are younger. Electricity is younger still. The world we recognize as modern is almost brand new. Ants have been running versions of civilization since before the asteroid. They farm fungi. They herd aphids. They build ventilation systems. They wage wars. They take slaves. They make rafts. They navigate by the sky. They turn bodies into bridges. They bury their dead. They build societies in which the individual is almost nothing and the collective is almost everything. There are about 12 megatons of dry carbon in ants, more than all the wild birds and wild mammals on Earth combined. The number is hard to hold because the animal is so small. 1 ant on your wrist feels like a speck of punctuation. 20 quadrillion ants is not a swarm. It is a planetary force spread thin enough to miss and thick enough to matter. That is why they will probably outlive us. Not because they are smarter, not because they are stronger, because they do not need the version of Earth that humans need. They can live under the ruins of it. The last human road will crack. Rain will enter. Seeds will catch in the dust. The names on the signs will bleach away. The buildings will become cliffs for roots and shade for beetles. Underneath, in the cool dark, workers will carry larvae through tunnels they made without blueprints. A queen will turn the stored memory of a single flight into another generation. The surface will change hands. The colony will continue. And the strangest ant story is not the one about surviving the end of the world. It is the one about the ant that used us to conquer it. 1 super colony. 6 continents. Billions of workers that smell like family. A global empire built in our cargo ships, our flower pots, our ports, and our walls.